Hi guys, this is O-Level Chemistry, paper 12, November 2017, question 11. Which sample contains the most atoms? 0.5 moles of water. So water is H2O. There are 3 atoms present in water. Therefore, 0.5 into 3 will give us 1.5 moles. The next one is 1 mole of carbon dioxide. So carbon dioxide is CO2. Therefore, 1 into 3, because there are 3 atoms present, is equal to 3 moles of atoms being present. Next, we have methane. Methane is CH4. So in total, there are 5 atoms present. 1 mole into 5 atoms is equal to 5 moles of atoms. And the next one is 2 moles of hydrogen chloride. Hydrogen chloride is HCl. There are 2 atoms present. So 2 moles into 2 atoms gives us a total of 4 moles of atoms. So the question has asked us which sample contains the most atoms. So out of the calculated moles of atoms, 5 moles is the largest value obtained, making option C the correct option for this question. Question 12. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? So AR of chlorine is 35.5. 1 mole of Cl2 has a mass of 35.5 into 2, which is equal to 71 grams. And they're asking us for 2 moles. So 2 moles will have how much mass? So this would become 2 upon 1 into 71, which will give us a value of 142 grams. This makes option D the correct option for this question. Question 13. 1 mole of an organic compound Q is completely burnt in oxygen and produces exactly 3 moles of water. Which compound is Q? So, in the general combustion equation, CXHY plus X plus Y upon 4 O2 gives us X CO2 and Y upon 2 H2O. So, we can use this Y value and this formula y upon 2 H2O to calculate the number of moles of water produced. All we need to do is find out the total number of hydrogen in the given compound. So in butane, we've got 10 hydrogen. So this would be 10 divided by 2, giving us 5 H2O, 5 moles of water. In the case of ethanol, there are 5 hydrogen listed as C2H5 and 1 hydrogen part of OH. So in total 6. So this would become 6 divided by 2, which is equal to 3 moles of water. For propane, there are 8 hydrogen atoms. So this would become 8 upon 2, which is equal to 4 moles of water being produced. And in propanol, it would be 7 plus 1, 8. 8 upon 2, which will give us 4 moles of water being produced. The question has asked us which will produce exactly 3 moles of water. So 3 moles of water are present here, making option B the correct option for this question. Question 14. In an experiment, 1 mole of powdered copper and 1 mole of powdered zinc are placed in a flask. Dilute acid containing 1 mole of acid is added to the flask. The flask is left until all the reactions, if any, are complete. Which diagram shows the result of the experiment? So colorless neutral solution and 1 mole of copper left. That means only zinc reacted and copper did not. Since zinc is more reactive than hydrogen, it will react. And since copper is less reactive than hydrogen, it will not react. So this is the correct observation for what is supposed to take place. Next, we have a blue neutral solution showing that copper reacted, producing soluble copper salt, which makes this incorrect. Next, we have a blue neutral solution and 1 mole of zinc showing copper reacted. This is incorrect. And also in B, the solid precipitate left is half mole of copper and half mole of zinc. This is actually showing both reacted. So still it's wrong because it's showing copper reacting. And in D, we've got colorless acidic solution and 1 mole of copper plus 1 mole of zinc. This shows that none of the two metals reacted, which is also incorrect. Therefore, the correct option for this question is Option A. Question 15. A simple cell can be made using two different metals as the electrodes and an aqueous solution as the electrolyte. Which statement about simple cells are correct? A greater voltage is produced using magnesium and silver than using magnesium and copper. This is correct because the greater the difference in reactivity, the greater the voltage produced. Magnesium and copper are very much different in reactivity. However, silver is less reactive than copper, so the difference between silver and magnesium would be greater than the reactivity difference between copper and magnesium. Next, the is an aqueous solution containing both positive and negative ions. Yes, it should be a soluble ionic solution. Next, the more reactive metal will release electrons. Yes, the more reactive metal gets oxidized and the less reactive one gets reduced. So all 3 points being correct makes option A the correct option for this question. Question 16. Magnesium can be produced by electrolysis of molten magnesium chloride. What are the equations for the reaction that occur at the positive electrode and the negative electrode? Okay, so the positive electrode is the anode, and anode is where oxidation takes place. Therefore, we would have 2Cl minus being oxidized to Cl2 while giving off 2 moles of electrons, and the negative electrode is the cathode where reduction takes place. So Mg2 positive ions would be accepting 2 moles of electrons, producing 1 mole of magnesium metal. So the positive electrode should have a reaction of chlorine and the negative electrode should have a reaction of magnesium. So all 4 options have chlorine present. Now, the reactant must be 2 moles of Cl negative ions, which is there in option A, option C, and option D. So option B has been eliminated. And for the negative electrode, the reactant must be Mg2 positive ion. Option A has H positive ion, so option A gets eliminated. Option C has Mg2 plus 2 electrons, giving us 1 mole of magnesium, which is correct. While D has Mg2 plus 2 moles of electron, giving us 2 moles of magnesium, which makes it incorrect. Therefore, the correct option for this question is option C. Question 17. Three different solutions were electrolyzed using inert electrodes. Solution 1 is aqueous sodium chloride. So the products would be hydrogen gas and oxygen gas because it is aqueous. Then we have concentrated hydrochloric acid. So this would produce hydrogen gas and chlorine gas. And next we have dilute sulfuric acid producing hydrogen gas and oxygen gas. Okay, which solution produce hydrogen at the negative electrode? All three of them have hydrogen being produced, making option A the correct option for this question. Question 18. Compound Y reacts with oxygen. This reaction has a positive enthalpy change of reaction, meaning it is endothermic. What information can be deduced about Y and its reaction with oxygen? Compound Y can be used as a fuel. It is an endothermic reaction. It is not producing energy. It is taking in energy. So no, a fuel needs to give off energy. Compound Y could be a hydrocarbon. No, there is no indication here that carbon and hydrogen are the only elements present in the compound because it reacts with oxygen. In the reaction, the energy needed to break the bonds is greater than the energy released when bonds are made. Yes, that is what makes this reaction endothermic. In the reaction, the products are at a lower energy level than the reactants. If this was the case, then this would have been an exothermic reaction. In this reaction, the products are at a higher energy level than the reactants because it is an endothermic reaction. So option C is the correct option for this question. Question 19. The formation of liquid water from hydrogen and oxygen may occur in three stages. In the first stage, 2 moles of hydrogen gas and 1 mole of oxygen gas are converted into 4 moles of hydrogen atoms and 2 moles of oxygen atoms. So bond breaking is taking place. So this reaction is endothermic. In the next step, we've got the atoms of hydrogen and oxygen joining together to form steam. So bond making is taking place. So this is exothermic. And the last one is steam condensing to liquid. So it's a change of state from gas to liquid. That means energy is released because the temperature is reduced. So this is also an exothermic reaction. The question asks which stages are endothermic. So only stage 1 is endothermic, making option B the correct option for this question. Question 20. Sulfur trioxide is produced by the following reaction. 2SO2 gas plus O2 gas gives 2SO3 gas, and the delta H is negative, making this an exothermic reaction. Which change in condition would produce a greater amount of SO3 at equilibrium? So the equilibrium needs to be favored in the forward direction. So adding a catalyst only speeds up the rate of reaction. It has no position on the equilibrium shifting towards the left or the right. Increasing the pressure. An increase in pressure favors the side with the lesser number of moles. So number of moles of reactant is 3, number of moles of products is 2. Therefore, the forward reaction would be favored. Increasing the temperature favors the endothermic side of the reaction. Since the forward reaction is exothermic, the reaction will be favored in the backward direction, making the reaction endothermic. Removing some SO2 and O2. SO2 and O2 are reactants. If the concentration of the reactant is decreased, the equilibrium will shift backwards to maintain the concentration of the reactants. So the question is asked us which change in condition would produce a greater amount of SO3 at equilibrium. That would be a shift of equilibrium towards the right. And the option that has the equilibrium shifting towards the right is B, making B the correct option for this question.